Grade 9 Science. In this video, I am going to talk about simple machines. What are called simple machines? Simple machines are the devices that are used to make our work easier. There are four types of simple machines. What are they? Lever, incline plane, pulley, wheel and axle. A metal rod or a crowbar can be used to lift a wooden log or a rock. So this is the type of a lever. Parts of a lever. The force applied on the lever downwards is known as the effort. Weight lifted by the lever is the load, or force overcome by the lever is the load. The point on the wooden strip that contact with the lever is called fulcrum or pivot. Load is at one end of the lever, effort is at the other end. Load is balanced by the effort over the fulcrum. Now refer to the diagram. The distance from the fulcrum to the effort is called effort arm. Distance from fulcrum to the load is called the load arm. Now we'll talk about types of levers. There are three types of levers. They are the first order lever or first class lever, second order lever or second class lever, third order lever or third class lever. First order lever. Levers in which the fulcrum acts between load and effort are called first order levers. Here always fulcrum is at the middle. These are some examples for first order levers. Then second order levers. Levers in which the load acts between effort and fulcrum are referred to as second order levers. Here always load is at the middle. Some examples for second order levers. Third order levers. In third order levers, effort acts between the load and the fulcrum. Always effort is at the middle. Examples: broom, fishing rod, and human arm. Now refer to this diagram. You can easily remember the types of levers by this diagram. First class lever, always fulcrum at the middle. Second class lever, always load at the middle. Third class lever, always effort at the middle. You can remember the word FLE. Mechanical advantage. What is known as the mechanical advantage? It is the ratio of load to effort of the machine. So mechanical advantage equals load over effort. What is the unit of mechanical advantage? Mechanical advantage equals load over effort. Load and effort both are forces. So they are measured in newtons. So newtons will be cancelled. So there is no unit for the mechanical advantage. What is the mechanical advantage if a load of 36 Newton is lifted by applying an effort of 12 Newtons? Mechanical advantage equals load over effort. Load is 36 Newtons, effort is 12 Newtons. Then mechanical advantage is 3. Velocity ratio of a machine. Velocity ratio of a machine is the ratio of the displacement of effort to the displacement of load at the same time. So velocity ratio equals displacement of effort over displacement of load. According to mathematics, same value can be obtained by dividing the length of effort arm by the length of load arm. So velocity ratio of a lever equals to the effort arm divided by load arm. Now do this calculation. Find the velocity ratio of the lever if Bx equals 60 cm and Ay equals 15 cm. The diagram is given. Velocity ratio equals displacement of effort over displacement of load. So velocity ratio of this lever equals 60 cm over 15 cm, that is 4. For velocity ratio also, there is no unit. Work input and work output. When we have to get work done from a machine, we have to work on the machine. Work done on the machine is called work input. When the work input is given to the machine, some amount of work is done by the machine also. Work done by the machine is known as work output. You can find the work done if you know the force and displacement. Work done always equal to the force into displacement. So work done on the lever means work input equals effort into displacement of effort. Work done by the lever equals work output, means work output equals load into displacement of load. So this can be applied for all the types of machine. Work input equals effort into displacement of effort. Work output equals load into displacement of load. What is the SI unit of work input and work output? Work done always equals the force into the displacement. Force is measured by newtons. Displacement is measured by meters. So newtons into meters, that is called Newton meters or joule. So SI unit of work is joules. The efficiency of a machine. Efficiency of a machine is the percentage of the work given out from the machine is for the work input. That means efficiency of a machine equals work output over work input. This can be represented as a percentage. Work output equals load into distance traveled by the load or displacement of the load. Work input equals effort into distance traveled by the effort or displacement of effort. Now here load over effort is the mechanical advantage. Then distance traveled by the load over distance traveled by the effort equals to the 1 over velocity ratio, because velocity ratio equals distance traveled by the effort divided by distance traveled by the load. So we can apply in the equation, then you can get efficiency equals mechanical advantage into 1 over velocity ratio. That means mechanical advantage over velocity ratio. Generally, efficiency of a machine is given as a percentage. So efficiency equals mechanical advantage over velocity ratio into 100. So this can be applied for all the types of machines, for levers, inclined planes, pulleys, wheel and axle. So try to remember all these equations. Mechanical advantage equal load over effort. Velocity ratio equals distance traveled by the effort over distance traveled by the load. At the same time, efficiency equals mechanical advantage over velocity ratio into 100. Right, now you can do this problem. Read the question and find your answers. After that, refer to the given answer. When a lever was used, the force applied on the lever was 300 newtons. The force overcome by the lever was 200 newtons. Displacement of the effort and the displacement of load respectively were 0.5 meters and 0.4 meters. Find the mechanical advantage of the lever. Find the velocity ratio of the lever. Find the efficiency of the lever. Mechanical advantage equals load over effort. 200 newtons over 300 newtons. So mechanical advantage is 0.667 or 2 over 3 as a fraction. Part 2, velocity ratio. Velocity ratio equals displacement of effort over displacement of load. 0.5 over 0.4. It is 1.25. Then you can find the efficiency of the machine. Efficiency equals mechanical advantage over velocity ratio into 100. Mechanical advantage is 0.667. Velocity ratio 1.25. So 0.667 over 1.25 into 100. When you simplify, you can get the answer 53.36. Now we'll talk about inclined plane. Inclined plane or ramp can be used to make a job easy. Therefore, inclined plane is also a simple machine. Now here AB is the inclined plane. We have to lift the weight, that is W. W is the load. Effort is E. AB is called the length of the inclined plane. Then BC is called the height of the inclined plane and theta is the angle. When we increase the angle of the inclined plane, effort also should be increased. If we decrease the angle, effort should be decreased. So with lesser effort, we can lift a load if the angle is less. Examples for inclined planes used in day-to-day life. The wedge, the staircase, the screw jack, screw nail, and the ladder. And there are so many, you can find more. Now you can do this problem. The weight of a barrel of oil is 600 newtons. Using an inclined plane of 4 meters long, it is lifted to the deck of a lorry, which is 1 meter high from the ground. The force exerted to push the barrel along the plane is 200 newtons. Draw a diagram and mark the given details. Find the mechanical advantage of the inclined plane. Find the velocity ratio of the inclined plane. Find the efficiency of the inclined plane. Find the work input. Find the work output. Find the efficiency of the inclined plane. Now we go to the part 1. You have to draw a diagram and mark the given details. So this is the inclined plane AB. Load is 600 newtons. Effort is 200 newtons. Length of the inclined plane is 4 meters. Height of the inclined plane is 1 meter. Then you can find the mechanical advantage. It is equal to the load over effort. 600 newtons over 200 newtons. The answer is 3. Part 2, velocity ratio of an inclined plane equals distance traveled by the effort over distance traveled by the load. So it is 4 meters over 1 meter, that is 4. Fourth part, efficiency of the inclined plane. Efficiency equals mechanical advantage over velocity ratio into 100. So 3 over 4 into 100. It is 75%. Work input. Work input equals effort into distance traveled by the effort. That is 200 newtons into 4 meters. Then your answer is 800 joules. Work output equals load into distance traveled by the load. 600 newtons into 1 meter. So the answer is 600 joules. By using work input and work output, you can find the efficiency. Efficiency of the inclined plane equals work output over input into 100. 600 joules over 800 joules into 100. So 75%. Now we talk about wheel and axle. As wheel and axle are connected to the force applied on the wheel can be transferred to axle to do the job. Windlass is such a machine with wheel and axle. The windlass is made by fixing an L-shaped handle to a long cylindrical stem, which is rested on the stand so that it can freely be turned. The rope is wound round the stem and bucket is tied to the other end of the rope. When the handle of the windlass is turned, the bucket goes down into the mine. When the handle is turned the other way, bucket comes up with the load filled into it. When the handle is turned once round, the rope also winds once round the stem. Now this is the wheel and axle. The radius of the wheel is R1. Radius of the axle is R2. When we apply the effort, it is moved. The displacement of effort equals to the circumference of the wheel. When the wheel make one rotation, axle also make one rotation. So distance or displacement moved by the load equals to the circumference of the axle. So you can find the velocity ratio of the wheel and axle. It is equal to the circumference of the circle with one turn of wheel over circumference of the stem. Circumference of a circle equals 2πr. So here circumference of the circle with one turn of wheel equals 2πr1. Circumference of the stem equal to 2πr2. Then 2π will be cancelled. So it is equal to r1 over r2. So velocity ratio of wheel and axle equal to the radius of wheel over radius of axle. So if you are given the radius of wheel and radius of axle, you can find the velocity ratio. If you are given the effort and load, then you can find the mechanical advantage. Then you can find the efficiency of wheel and axle. These are some examples for wheel and axle. Rotating handle, the device which is used to unpack screw nuts in tires, screwdriver. Now we'll talk about pulleys. It is easier to pull a bucket of water from a well using a pulley rather than pulling directly the bucket of water with the straw. So pulley is a simple machine. Now refer to this diagram. When we use this pulley, if we neglect the friction between the rope and the pulley, effort equals to the load. So mechanical advantage of the pulley equals effort over load. If both are equal, the mechanical advantage will be 1. And when we move effort with 1 meter, load also moves with 1 meter. Then the velocity ratio equals distance traveled by the effort over distance traveled by the load. Then it is also 1. Then the efficiency will be 100%. But there is no machine in the world with 100% percentage because here friction is there, or when machines are operated, heat is generated. So always efficiency of the machine is less than 100%. Remember that. Right. When we are lifting something straight upwards, the force should be applied upwards. But when we are using a pulley for this purpose, the pulling force can be turned appropriately. Applying a force downwards is easier than applying it upwards. Therefore, it is easy to use a simple single pulley to lift a load. The weight of a bucket full of water is 12 newtons. It is lifted up using a pulley. Assume that pulley causes no friction. Then you can find the mechanical advantage, velocity ratio, work input, work output, the efficiency of the pulley. Mechanical advantage equals load over effort. If load effort is 12 newtons, load also 12 newtons if we neglect the friction. So mechanical advantage is 1. Velocity ratio, when the effort travels same distance, load also travels the same distance. Therefore, velocity ratio is 1. Now let us see work input for the machine. Work input for the machine equals effort into displacement of the effort or distance traveled by the effort. So let's take the distance traveled by the effort as 0.8 meters. Then work input equals 12 into 0.8 meters. It is 9.6 joules. Now let's see the work output of the machine. Work output equals load into distance traveled by the load. So load is 12 newtons, distance is equal to the earlier distance, so it is 0.8. Then the work output of the pulley is 9.6 joules. Then you can find the efficiency. Efficiency equals mechanical advantage over velocity ratio into 100. So it is 1 over 1 into 100, then 100%. Pulley systems. The motion of a pulley used to draw water from a well is turning round its axis only. Such pulleys are known as stationary pulleys or fixed pulleys. Other than these, there are pulley systems with moving pulleys. Mechanical advantage of a pulley system can be increased largely by using several stationary and moving pulleys. Crane is a complete machine consists of pulley systems. So we can easily lift a heavy load with a lesser effort. Complex machines are assembled using several simple machines. Now you can see this diagram, bicycle. Here you can find many simple machines. Brakes, there are levers there, wheel and axle, then cogwheel and chain, pulley systems are there, pedal, wheel and axle is there. So that's only in this lesson that you have to learn. So we'll meet again in another video. You can subscribe my channel to get the next video quickly. Thank you.